A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly, kindly confirm the same. Thank you. Sahil, is it mandatory wherever is canyon there is a river? Absolutely not. That is where you have the turbidity currents, which also create canyons in certain areas. Siddhant, why Mediterranean region receives winter rainfall? That is because during the summer conditions and during the summer season, there you have the subtropical high pressure belt. During the winter season, the subtropical high pressure belt shifts to the south. So that area experiences westerlies. Westerlies pick up moisture from the Mediterranean Sea and brings rainfall in that area. Pranay, absolutely helpful. Absolutely helpful. Taking up one at a time will not help it or will not let it become another burden for you. What does it call between India and Sri Lanka? Priyanka, I hope you are asking about Pok Strait. That is the narrow water channel which separates India and Sri Lanka. Mukkalvar, why weather changes suddenly, sometimes from sunny to rainy? So there are multiple factors. The increased amount of evaporation, condensation, which can happen. The winds bring in various different types of clouds. So that is why we on the ground surface we don't even realize what is the wind direction in the upper atmosphere. So they can also bring out various different clouds. So that is why. Shamil, I saw the winds on the website earth.com. Yes, Shamil, in fact, if you take a look at it, so those basic wind patterns, I urge you to analyze it at different latitudes as well. You'll get a lot of clarity in that. Devansh, when there is subtropical westerly jet over India in winters, then there is no movement of onshore winds in India? No. Only in the region around the Coromandel coast. That is where you have the trade winds which move. They bring onshore winds, or they become a kind of onshore winds and they bring rainfall. Priyanka, in between India and Sri Lanka, you don't have an isthmus. Isthmus is a land area which connects to other land bodies. And there you don't have land, you have a submerged portion. So that kind of a feature you find across many different islands of the world. In fact, you will find many of the islands in Southeast Asia and South Asia and also in the region of Western Pacific. Many of the islands, while they are separated and there is water in between, underneath that water you will find a kind of a substructure which ends up joining them. So that is not referred to as an isthmus. You need a kind of a landmass which joins them. So that is not there in between India and Sri Lanka. Farhan, in recent news, 5 planets in a row. What's the condition? So it is basically, Farhan, see, the planets, they rotate, right, and revolve around the sun. And you have to understand that the sun is not stationary either. It is not as if the sun is at one place. Sun is also moving at an incredibly high speed of hundreds and thousands of kilometers per hour, and sun is moving around the Milky Way, right? Because Milky Way is a galaxy and sun is a star. So there, as the sun is moving, the planets keep on moving around the sun as well. So there are positions, there are conditions when the other planets, when viewed from a point of view, they will give you an appearance of standing in a straight line. So that is something which has happened. Biswajit, good Biswajit, kindly revise more and it will be much easier for you to digest the things that we read. Uh, are isthmus and tombolos the same, Himaya? Absolutely not. Tombolos basically, they in a way connect a small tide island of sorts. A small island is tied to the mainland with the help of a tombolo. In the case of an isthmus, you have larger landmass. You have very large landmass. The landmass is the size of a country or maybe a continent even. Take the case of Isthmus of Kra. Now here, the region around Thailand, that is where it connects the land with the Malayan Peninsula as well. So take the case of Isthmus of Panama. It connects North America and South America. Take the case of Isthmus of Suez. It connects the region of Asia with the region of Africa. So that is what is an isthmus. These are large areas. Sahil, we can see Mars also. Mars is also visible with naked eyes. In fact, around generally, if the sky is clear, around 6 to 7 p.m., you'll be able to look at the red planet as well. Is it necessary to remember the pie chart of Köppen classification for exam? Amit, absolutely not, my dear friend. Please don't learn all of that. See, we have discussed the PYQs there. So only based on those PYQs, why did we discuss the PYQs? To give you an idea about what kind of questions are going to come. So UPSC is never going to ask you data-centric question. Please be very clear in that. UPSC doesn't like to ask data-centric questions. And for that, it holds other examination for other grades so that people who are good at learning data, they are going to work under you. So please don't start learning data anywhere, at least in the subject of geography, I can say with full surety. Even if a question requires few data pointers here and there, that is just used as a diversion in the question. That is just used as a diversion in order to deviate your attention from the larger point that UPSC is trying to make. For example, we discussed a previous year question where UPSC had asked in a statement that the temperature in the eye of the cyclone is 10 degrees C lower than the surroundings. Now here 10 degrees C is a data point. Ideally, many of the candidates, they immediately got nervous that we have not learned this, we have not come across this. That is why they committed a mistake there. But with that 10 degrees C, by mentioning that, UPSC hid the portion of the incorrect statement that it is 10 degrees C lesser. So wherever data is used, in the case of geography and these subjects, it is mostly used as a method of diversion. So please don't learn that. Devansh, that is more than enough. And Pranay, you said that cirrus clouds become red in color in evening. That is because of refraction of light. You have refraction as the light enters through. So I hope we are aware that basically the sunlight which is emitted is in different spectrums of wavelength. You have VIBGYOR, violet, indigo, blue, yellow, orange. So that is where you have VIBGYOR. So there, red is the or it is the lower wavelength of sorts. So that is why when you have the sun at the position of horizon, that is where these infrared rays or to the reddish end of the spectrum lights which are emitted, they are refracted by the clouds, the cirrus clouds, and that is why they appear reddish even at the time of sunset, even at the time of sunrise. So VIBGYOR fundamental. So that is where the long wavelengths rather, they are reddish in appearance. Yeram Sethi, can I believe that planets revolve around the sun as satellites revolving around the sun? And the sun is revolving around which thing? It is revolving around the center of the Milky Way, right? That is what it is revolving around, the central position of the Milky Way. Around that is the entire thing which holds the Milky Way together. And it is said that at the center, you have the presence of a kind of a black hole. So that is what has got enough gravitational pull to have all the various stars, hundreds and thousands and billions of stars held together in any particular galaxy. Savita, Köppen gave classification EF and ET. Taiga is not included. Taiga is basically, Savita, the areas of coniferous forests. So taiga vegetation you will find, or boreal vegetation as it is referred to, in D categories, right? So in D climate, D group of climate, that is where you will find taiga conditions to prevail. Okay. And Shamil, why more tropical cyclones occur in Bay of Bengal as compared to Arabian Sea? First of all, we have a few reasons, very straightforward, that Bay of Bengal is much smaller, so it gets heated at a greater rate, and that is why you have, because it gets heated at a greater rate, you have the formation of a tropical cyclone. Again, we saw that during during La Nina conditions, during the normal Walker circulation, during the neutral phase of IOD, during the negative phase of IOD. In all these cases, cyclones will occur in the Bay of Bengal. Only during El Nino and positive IOD will you have cyclonic circulation which occurs in the region of Arabian Sea. So these are the major factors. And also, one of the other factor is something that we are going to study here when we study about the stratification of oceanic water, that the influx of large number of rivers in the region of South China Sea, in the region of Bay of Bengal, in the region of Gulf of Mexico as well, where you have large number of rivers emptying their water, that also in a way encourages the formation of more tropical cyclones. Okay. Right. So now we continue from where we left off. So yesterday we had talked about the bottom relief features of the oceans, what constitutes the bottom relief. We had taken up one of the questions as practice as well, the subjective type question. I hope you would have tried to write it out. If not, do it today or tomorrow or in the weekend. I want you to write an answer to that question as well. Then we had given some areas for map pointing. How many of us pointed out those areas or looked at those areas in the atlas or the map? The map pointing that we gave yesterday. Very good. Beautiful. And please understand the larger purpose here. The larger purpose is to help you be more aware about, for example, if I tell you Cook Strait, that locate where Cook Strait is. So when you take a look at it, you look at the peripheral areas as well, that, okay, this is situated near New Zealand. New Zealand has got these kind of phenomena. So that is where all the map pointing things that we have given to you and that you have looked at, I hope that you're looking at it in an explorative manner and you are also looking at things in the vicinity. That is something which is going to make your learning much more long lasting rather than being restricted to a kind of a list like a guide. Okay. So now today, what is it that we are going to study? We are going to study about the horizontal distribution of temperature across the water bodies. Why is it that temperature across the oceans, they vary if you are present in the region of equator in Atlantic Ocean? The temperature that you experience along the sea surface is going to be very different as compared to, let's suppose, when you are present in the Mediterranean Sea or when you are standing in the region of Bay of Bengal. So that is the horizontal distribution of temperature. So why is it that horizontally, as you move from one water body to the other, the temperature tends to change so drastically and rapidly? And then we are going to look at the vertical distribution of temperature as well, that as we start going into the depth, what is the distribution of temperature which is experienced. Then after that, we are going to study the salinity. How is it that oceanic salinity tends to vary? What do we understand by oceanic salinity? And how is it that in certain cases, oceanic salinity and a variation of it can also induce a kind of a circulation amongst the various different oceans? We are also going to take a look into, for example, how the difference of salinity in between Arabian Sea and Bay of Bengal, that can trigger more tropical cyclones in the region of Bay of Bengal. Again, many of these portions you will not find to be mentioned in any of the reference books. So these are taken from the portions of current affairs. So I would urge you, kindly pay attention here. Then we are going to look into the major portions, that is the occurrence of ocean currents, global thermohaline circulation, tides, how do they occur, why do they occur, and also about coral reefs. So that is something that we are going to address today. We are going to start with the portion of temperature, then we will move on into salinity and further ahead. So we were discussing about sun being the main source of or the main provider of heat when it comes to the oceanic areas. Sun is the main provider of heat, main source of heat. So here, if sun is the main provider of heat, we have seen that even in the case of the land masses, sun was the main provider of heat. But across different portions of the planet, different land masses, they exhibit different ranges of temperature. Similarly, across the water bodies as well, you have various different factors which contribute to variation in temperature experienced across different regions of the oceans. Now, here, all that you have to do when we talk about the various reasons is you have to try to look at the basic common sense and the common concept, that how is it or why is it that a particular region will experience a kind of a temperature, or a particular region, let's say, will not experience very hot conditions, cold conditions. So if you follow your logic, that will give you the answer enough. So we take a look at the factors affecting temperature distribution, and this is the horizontal distribution. Horizontal distribution. So first is the factor of latitude. That is the latitudinal position of any particular water body. We do know that based upon the latitudinal location, you have varying amount of solar insolation which is received. We do know that at lower latitudes, we receive higher amount of solar insolation. And as we start moving to the regions of the higher latitude, the solar insolation reduces, thereby impacting the temperature experienced as well. So surface water temperature generally, under general condition, decreases from equator to the poles. This is the general trend. Okay? General trend. Why? Because the insolation also reduces as you move from equator to the poles, and also resultantly you will find that as the solar insolation also ends up reducing, thereby you have different types of temperature experienced. Then we have unequal distribution of land and water. So we know by now that northern hemisphere is dominated by land masses, whereas the southern hemisphere is dominated by water bodies, right? So, and also another factor that we know while we were studying about temperature and climate is basically that land ends up losing and gaining heat very quickly, whereas water body, it takes a larger amount of time to exhibit a change in temperature. Even by 1 degree Celsius, water bodies will take a much larger point of time. So we can always say that in the region where you have water bodies, or water bodies are in dominance, temperature will be changing very gradually, very slowly, and in a homogeneous manner. Whereas wherever you have dominance of land masses, we can say that temperature changes quite rapidly. While we were studying isotherms in the portion of module 6, that is the atmosphere and temperature. So while studying those isotherms also, if you recall, we had looked at the fact that in the northern hemisphere, the temperature distribution was absolutely skewed due to the presence or the dominance of the land masses. Whereas in the southern hemisphere, the isotherms were almost parallel to the latitudes, indicating a very uniform and a homogeneous change in temperature. It is because of this characteristic that water bodies in the northern hemisphere, they get heated to a greater extent because of the predominance of the land masses, especially across the lower latitudes. Water bodies tend to get more heated up. In general, you will find that oceans in northern hemisphere has more contact with land as compared to southern hemisphere. So more heat is received as an influence of the land masses as well. Also, in lower latitudes, water in northern hemisphere, please don't get confused that a glass of water is saying that it will become more hot in northern hemisphere. No. By water, I mean water body. Okay, let me write it. Water bodies in northern hemisphere get more heated. Why? due to influence of land mass. Influence of land. So for example, a land area gets very heated up and it is in contact with the water body. So some of that heat will pass on as a result of the convection movement, etc., into the water body as well. So the water also, as we have seen in the case of Indian Ocean Dipole, isn't it? We saw that when the Arabian Peninsula and the Horn of Africa gets superbly heated up, we have a positive IOD. You have warmer waters which exist in that area. Similarly, in the case of the neutral phase and the negative phase of IOD, we have also realized and we have also seen there that the heating of the land mass and in the form of the islands that are prevalent, so heating also creates a heating of the water body nearby. That is what creates the neutral phase of IOD or the negative phase of IOD. So that is where the influence of land mass into water body also comes into play. Now, then after that, the aspect of prevailing winds, the role played by the prevailing winds. Prevailing means what? Something which is in existence. Prevailing means existent wind patterns. So this refers to existent wind patterns. So for example, when we talk about these prevailing winds, here in any particular region, when we say these winds, we don't mean onshore or offshore or any local wind for that matter. Here mostly we refer to the permanent wind system. Permanent wind system. Okay. So when these permanent wind systems, they are in existence in any place, so there they can either be onshore, they can either be offshore. When they are onshore, that means they are coming over to the land. So onshore winds, what do they do in the case of sea surface temperature? So we have seen earlier that winds come over to the land. Let's suppose here you have the water body. When the winds come over to the land, they will carry the warm surface water along with them and they will eventually lead to downwelling. So onshore winds lead to downwelling. And due to which, what happens to the sea surface temperature here? What will be the sea surface temperature in the coastline? The sea surface temperature tends to increase because of significant accumulation of warm surface water. So sea surface temperature increases. Sea surface temperature increases. Whereas whenever you have the winds which become offshore, they will carry the surface water away from the coastline, as a result of which there will be upwelling. And upwelling, what does it do to the sea surface temperature? It reduces the sea surface temperature, isn't it? So offshore winds result in upwelling of cold water from below, driving away warm surface water, thereby decreasing the sea surface temperature that we experience in that area. That temperature which we experience, that is reduced. Now, all these logics that we are studying about, you need to interrelate it, interconnect it. How? We have seen that you have the conditions of downwelling leading to high sea surface temperature, isn't it? So, downwelling leads to high sea surface temperature. That is something we know. Now, let us take a look at it. What is it that we can conclude from here? Or how does that help us understand anything for that matter? Let's suppose. So here, if you generally look at the wind patterns and the wind movement, the trade winds are going to be like this, isn't it? So in the region of South China Sea, will we experience downwelling? Yes, we will experience downwelling. In this region also, the winds, normally trade winds are like this, especially during the months of November, December, January, right? So if not January, at least till November and December. So here also there will be downwelling. Then wind patterns are going to be like this here as well. Or even if let's say it reverses, in the region of Gulf of Mexico, still it will lead to downwelling in some portion or the other of Gulf of Mexico, isn't it? So because of this, can we not say that the sea surface temperature in Gulf of Mexico, in South China Sea, in Bay of Bengal tends to increase quite frequently? So we can say that, exaggerated by the fact that regions around Bay of Bengal, they are very narrowly surrounded by land. So land gets heated up, the water will get heated up. The land gets heated up, the water will get heated up. The land gets heated up, the water gets heated up. Due to which the sea surface temperature in these three water bodies tends to escalate rapidly. And when the sea surface temperature escalates rapidly, which atmospheric phenomena results, or what is the atmospheric phenomena that we observe as a result of it? Let me see. Tropical cyclones. So that is why these three regions, they are frequented by more tropical cyclones. So like that, whenever you come across such different factors, whichever will lead to higher sea surface temperature in any part, whichever will facilitate a greater heating of water body in any portion, that will lead to tropical cyclones. So that is why Bay of Bengal or South China Sea or Gulf of Mexico experiences more tropical cyclones. You have multiple reasons rather than only one. Okay. Now, then we have the ocean currents. Ocean currents. What are ocean currents? Ocean currents basically are a defined, a streamlined movement which is observed in oceanic water, where you have a definite volume of water consistently moving in a certain direction. That is what is oceanic current. Now it is of two categories: warm ocean current, cold ocean current. Again, something that we are going to study later today. So these oceanic currents, they are known by their characteristics of temperature, whether they are warm, whether they are cold. Now, when you have warmer waters which enter into any area which is otherwise colder, it will increase the temperature of that area. Otherwise, when you have colder ocean currents coming to any area which is warmer, it will provide cooling to the waters in those areas, isn't it? So that is why warm ocean currents raise the temperature in cold areas, while the cold currents decrease the temperature in warmer areas. It is in fact this precise reason due to which the presence of a warm ocean current in the northern Atlantic keeps the water in that region ice-free for most of the year. In fact, if you look at this one, the temperature, the thermal image here, you have the presence of a warm ocean current in the northern Atlantic. And that is responsible for keeping many areas in the region of North Atlantic ice-free for most of the year and opening it up for trading activities and other navigational purposes. So that is how ocean currents also tend to influence the sea surface temperature quite significantly. Think about the role played by advection when we talked about advection in atmospheric circulation, that how advection also helps. So you have cold winds coming in warmer area, cooling the region, warm winds coming in colder area, warming a region. So just like advection, the same role is played by ocean currents in terms of distribution of temperature in oceanic water. Cold ocean currents come in an area, they will cool down that region. Warm ocean currents come in an area, they will heat up that region. So it is very similar to that of advectional process. Okay. Now, here we also have the distribution or the impact of temperature which is observed, which is experienced in the case of water bodies which are open. For example, take the case of the oceans. Oceans, they are surrounded by landmass, but they are not enclosed. They are not short or a small water body. These are large, which are open seas. So open seas versus enclosed seas. Open seas here refer to oceans, larger water bodies. Now here, the temperature also ends up varying if an area or if a water body is surrounded by landmass. For example, take the case of here, the Mediterranean Sea. Right? Let's suppose we take the case of Mediterranean. Mediterranean is located roughly at a latitude around 40-45 degrees, right? That is where Mediterranean is located. So it will still be counted as middle latitude. And it is closely surrounded by land masses from all sides. These land masses will get superheated. Now, when these land masses get superheated, they will have an influence on the water body as well. So when you compare the temperature of Mediterranean to the temperature observed across Atlantic at the same latitude, do you think it will be similar? Absolutely not. Here, in the case of Mediterranean, the influence of the closely surrounded land masses will be observed, will be felt to a much greater extent. So that is why wherever you have an enclosed sea or an enclosed water body, the temperature tends to vary. For example, if that water body is in lower latitude means it receives higher amount of heat. So the water body will experience higher temperature as compared to open seas like Atlantic, Pacific, and so on. Isn't it? So at low latitudes, enclosed seas have higher temperature. Why? Because the land gets heated significantly. Land gets heated more. Right? Whereas when we talk about higher latitudes, closer to the poles, there insulation is less. So the nearby land areas will be very cold, isn't it? So for example, if you take any of the water bodies in higher latitudes, the surrounding land areas will be much colder, due to which the water body will also be much colder. Now, that cooling effect won't be observed in the open ocean, right? That significant cooling effect won't be observed in the open ocean because the land is not surrounding it so much. So that is why in higher latitudes, the enclosed water bodies will be much colder because of the influence of landmass. So at high latitudes, open seas have higher temperature, enclosed seas have lower temperature. Yes, I like Baltic, Gulf of Bothnia as well. Those are the areas. So enclosed seas have lower temperature due to cooling of landmass. Okay. So this again is a factor which influences the temperature. So what are the overall factors that we have looked at? Latitudinal extent of the water body, unequal distribution of land and water, the existence of various different prevailing winds, whether they cause upwelling or downwelling in an area. Then after that, the various ocean currents which are in existence. Then after that, also whether a water body is enclosed by land from all sides or whether it is open ocean. So for example, this is the thermal image depicting temperature. Observe how in the southern hemisphere, the temperature changes very uniformly, very gradually, almost as if it is parallel to the latitudinal extent. Whereas in the northern hemisphere, that is not the case at all. In the northern hemisphere, there again, if you want to observe a kind of a similarity, observe how in the region of Pacific, because Pacific is a larger ocean, you will observe a kind of a gradual change in certain cases. But wherever land masses are dominant, the influence of land masses would be significant. Now here, what concerns us is basically the region of Bay of Bengal and the region of Arabian Sea. So if you look at these two water bodies, Bay of Bengal and Arabian Sea, now generally when we look at the map of the country, we are unable to fathom that which is bigger, which is smaller. But when you take a look at this map, it becomes very apparent, very clear that the region of Bay of Bengal is much closely surrounded by land masses as compared to Arabian Sea. So as a result of that, you will have greater influence of the land masses when it comes to heating as compared to Arabian Sea. It is much broader, much wider. So heating takes time generally. In this, high temperature is reached very quickly. Again, a reason why Bay of Bengal experiences more cyclones. Also, warm water from the region of Western Pacific oftentimes does pass through into the region of Bay of Bengal, right? Now, that again creates conditions for formation of more tropical cyclones in this region. Then, after that, we come to the vertical distribution of temperature. That is, how does temperature indicate a variation as you move vertically downwards? What is the variation indicated by water in terms of temperature? So we do know that sun is the main source of heat energy. It is the solar heat, the solar energy. But the solar light won't be available till the bottom of the ocean. Ocean has got a depth of close to around 4 to 6 kilometers from the sea surface. 4 to 6 kilometers of nothing but only water. That is present in oceans. Whereas solar light is available at max up till a few hundred meters. Not even, in most of the cases, not even till 1 kilometer. So broadly, the water body is divided into two broader zones. You have the photic zone, which receives sunlight, and you have the aphotic zone, which is devoid of sunlight. So these are the two basic zones, photic zone and an aphotic zone. So aphotic zone means devoid of sunlight. Whereas in the photic zone, you have the availability of sunlight. So obviously, by common sense and logic, we can think about it that where there is no availability of sunlight, there the heating will be much less, isn't it? So that is why when we talk about the temperature variation from the surface to the depth, the temperature at the surface is going to be generally the highest, whereas it will start reducing as we go further in the depth, isn't it? So that is where the temperature variation exists. So if you have to, let's say, depict a chart of the variation in temperature due to increasing depth, and let's say this is the temperature, right? So let's say this is the surface, and then depth of 1 kilometer, depth of 2 kilometer, 3 kilometer, 4 and 5 kilometer. Let's suppose. Now, when we talk about tropical waters, on an average, what do you think will be the temperature in the tropical waters on an average? It is roughly between 24 to 26 degrees Celsius. That is the temperature experienced in the tropical waters across the world. So let's assume the temperature is 25 degrees Celsius. Right? Now, as long as the sunlight is available, heat will be present. But as soon as you start going into the depth, the intensity of sunlight will reduce. As the intensity of sunlight reduces, the temperature experienced also tends to reduce, right? So the temperature will start indicating a drop as you move into the depth, right? Till suddenly, the availability of sunlight becomes very minimal in this area between photic and aphotic zone, which is also sometimes referred to as the zone of diffused light or the zone of a zone of transition in a way. So here you will find that the temperature starts reducing suddenly till you enter the aphotic zone. Aphotic zone is permanent darkness devoid of sunlight. So when you enter that area where there is no sunlight, and sunlight has not been prevalent there for a long period of time, so obviously the temperature will remain constant there. It will be very cold. And it is mostly, you will observe the temperature is between 3 to 4 degrees Celsius. 3 to 4 degrees Celsius. So the temperature tends to remain constant. Now, generally, what will the common logic say? That farther away from the surface we go, the colder the condition should be. So why isn't it that at the bottom the temperature is not 0 degree or -1 degree or -2 degree? When we are at a depth of 5 kilometers, 6 kilometers, why is it that the temperature is consistent only around 3 to 4 degrees Celsius? That is because of a very unique property of water. The unique property of water is that water experiences or exhibits its highest density at what temperature? What is the temperature at which water will exhibit its highest density? Beautiful. 4 degrees Celsius. So because water experiences its highest density means maximum compression at 4 degrees Celsius. So beyond that, if you cool the water, it starts getting converted into ice-like format, and ice is an expanded form of water. So for water at the lower level to, let's say, exist at 0 degree, water will need to expand. But the overlying pressure of kilometers thick of water column, will it allow the water to expand? No, it will not allow it. So that is why water tends to maintain that temperature of the highest density form. But then it could also have been very cold even at that particular density. Why it is not so? Because some amount of heat is also produced. Why? Because of the overlying pressure of kilometers thick of water. That overlying pressure induces some amount of heat as well. And that heat is significantly utilized by the organisms which roam around the ocean floor. And that is a heat referred to as hydrothermal heat, which is exerted because of the pressure which is in existence above the water column. The pressure is humongous, guys. Please don't have any second thought that what will be the pressure. Pressure can be withstood easily. No. All the major submarines, the large submarines that you see, none of them have the capacity. Majority of them don't have the capacity to go below 2 kilometers. Majority of them. Because if one of the submarines, if at all it enters into the area of around 4 or 5 kilometers depth, what will happen to the submarine is just like you have the soda cans, right, of Coca-Cola, Pepsi, etc., how you crush the empty cans, that easily the submarines will be crushed under the force of water. So that is the humongous pressure exerted by water. That is why when India has launched the Samudrayan mission to explore the depth of the Indian Ocean, India had to devise a specified or a special vessel for that, a special vehicle for that, which can go underwater and can withstand that much amount of pressure. So it is because of high pressure that generates some heat, and also water being at its densest at around 4 degrees. That is why at a depth, you will observe the temperature to be mostly around 4 degrees Celsius. Now, as you move at a depth, you observe that the temperature starts changing very radically, very drastically as we move from the photic to the aphotic zone. So that is where the change of temperature which happens is very drastic. Change of temperature is very drastic as one moves from photic to aphotic zone. Now this zone where the change of temperature becomes very drastic, that is what is referred to as a thermocline. That is the change in temperature, thermocline. So the region where there is rapid decline of temperature, it can extend from 100 meters depth to around 400 meters depth below the sea level and can further extend downwards. Now, the surface temperature can vary in different parts of the world depending upon the latitude, unequal distribution of land and water, prevailing wind systems, ocean currents, enclosed sea, open sea. So because of various factors, the surface temperature can vary. But the temperature at the bottom is largely common. Okay, so temperature at the bottom, so surface temperature can indicate a variation. Whereas bottom temperature across oceans is consistent, or rather similar. Similar how much? Around 4 degrees Celsius. 3.5, 4.5, roughly around that. So the surface temperature is varying, bottom temperature is consistent, means what? There will be a zone of transition where the temperature will suddenly change as we move from an area of sunlight to an area which is devoid of sunlight, right? Isn't it? So that zone of transition is referred to as thermocline. So thermocline is a zone of transition where temperature changes suddenly. Right? That is what is thermocline. Similarly, you have also a zone which we will study where salinity also changes drastically. So that is what is halocline. So as you move to the depths, water is largely having a kind of a consistent pattern because sunlight has not been available for many years in that region, millions of years. So there is a consistent pattern at the bottom. All the variations, major variations that we see in the oceans, that is happening on the surface itself. At max up till a depth of almost half a kilometer from the surface, that is where majority of the variations are taking place. At the bottom, it is an undisturbed biosphere which is there, or undisturbed ecology and ecosystem which exists. And that ecosystem has not been disturbed for many millions of years. That is why the species which you find at the bottom in the aphotic zone, many of them have been in existence for millions of years, and the evolution rate is also slow because the conditions around them, they are not changing drastically, right? So that is about the portion of temperature variation. Now we come to the portion of oceanic salinity. That is, what do we mean by ocean salinity? So salinity of anything means what? Salt content. How much of salt content is present, that is what indicates salinity, right? So a solution which has got a greater salt content will be more saline. A solution which has got lesser salt content will be less saline. So as compared to the river waters, the groundwater, the water that you have in the lakes, the ponds, etc., these are having lesser amount of salt content because generally they get fresh water. The rivers also, because they are consistently in motion, you don't have lot of various particles in it, so the salt content is less. Now when we say salt content, what do we mean by salt here? Does salt only refer to the common salt that we consume, or does salt refer to something else as well? So in a larger water body like ocean, You have various different ions, various different compounds, which are present in very small solid state. For example, you have calcium, you have carbonate, you have magnesium, you have potassium, you have chlorine, you have sodium. So you have various different compounds which are present. All these compounds, they refer to as, or they are referred to as, the salt content. So when we refer to a salt content in any water body, that basically means how much amount of these materials they are present or they are dissolved in water. Okay, so generally the oceanic water, the sea surface, etc., they are saline in nature because of various factors, because of the conditions. For example, you have underwater volcanic eruptions. They release a lot of materials which eventually they get saturated in terms of water presence, so they also add to the salt content. Naturally, when these oceans, they are next to the various different rocks and various different land masses, slowly and steadily they will keep on dissolving those materials, adding those materials as salt content. Rivers also bring some amount of salt content, that will also add to it. So you have various factors which add to the salt content in the oceans, right? Similarly, you have various factors which remove the salt content from oceans as well. So the salt content which is present in ocean, that is depicted by what we refer to as oceanic salinity. And it is something which is expressed in grams of material which is dissolved in per kg of water. So grams of material, so expressed in, Biswajit, yes, grams of material dissolved in 1 kg or 1000 grams of water. Okay, that means here we have parts, it is expressed in parts per 1000 grams, or simply parts per 1000. That is how salinity is generally expressed. Here also we will follow the same fundamental that we followed in the terms of variation of temperature. That is, first of all, we'll take a look at what are the factors which influence the variation of salinity as we move horizontally from one ocean to another. Then what are the factors which influence salinity as we move from one surface to the depth. That is, how does the salinity vary with respect to depth as well. So here, the total content of dissolved salts in seawater is called as salinity, right? It is calculated as the amount of salt in grams dissolved in seawater of 1000 grams. It is expressed as parts per 1000 or PPT, represented by the symbol like this. Okay, percentage is represented how? Percentage is generally represented here, and there you get an idea in hundreds, it is thousands. So that is why the double zero there. So that is parts per 1000. On an average, the average salinity of the waters, average salinity is around 35 parts per 1000, or expressed as 35 parts per 1000 like this. That is the average salinity. That means in 1 kg of water, you have 35 grams of dissolved salt content. Okay. Seawater is primarily made up of many ions with chlorine, sodium, and sulfate predominating. In fact, if you consider all the various ions, chlorine and sodium, they are the most dominant ions present across all the seawater, right? This is most dominant. These two, they are going to be most dominant. That is why it is by evaporation of seawater that you have the manufacturing of salt, which is done in many of the cases. And also, if ever you have ventured out into the sea, if you tried swimming in the sea, or if you have simply gone there and had a good time. Whenever water comes in, you would have experienced a kind of a salty taste. I don't recommend you to start drinking seawater because that will basically ruin your digestive system and it can lead to multiple different defects. So please don't start drinking seawater to experience that salt. Randomly, if you ever get that taste, you will experience that saltiness that is given by sodium chloride, NaCl, the common salt that we have. So when we talk about the various different salts which are present, so you have various sources which add on to the salt presence, various different sources which add on to the salt present in the seawater, as well as various different factors due to which salt from time to time keeps on getting removed from the seawater. Because otherwise, think about it, volcanic eruption, surface runoff, then dissolving the salt from the nearby coastal areas, all of this is continuously present and has been present for billions of years. So, if that would have been the case that there is always net addition of salt in the ocean, presently the salt content in oceans would have been very significant, very huge. But the salt content is maintained roughly at around 35 parts per thousand. Means that salt would be consumed somewhere as well. There would be some methodology by which that salt is removed as well. So basically, you will find that all the salts or the ions, they are added to the water by generally discharged by the river actions and the runoff that you have. Then you have volcanic eruptions underwater and also activities at mid-oceanic ridges. All of these, they keep on adding salts to the water. But at the same time, when the waves crash on the coastline, whenever you have experienced a wave, if ever you have experienced a wave crashing near a rock and crashing on the coastline, not the silent kind of a wave which comes to a beach, says hello to you and goes back, not that kind. The ones where large waves are generated which crash or which have a significant force when they hit a rock. So in those cases, you would have observed that significant amount of seawater is lifted up as a spray, like spray of water. As it hits the rocks, there's a lot of spray. Much of that spray is taken up by the winds and carried in the upper atmosphere. And that spray also consists of these salts. Now, that spray, when it is carried by the winds into the upper atmosphere, those salts are also carried into the upper atmosphere. When these salts reach the region around tropopause or even lower than that, these salts, they start acting as hydroscopic nuclei and they start serving as the base around which clouds can be formed. So that is why it is said that sea sprays or the sprays generated by the sea waves, they are very instrumental in causation of rainfall in different parts of the world. Because when they crash, that is when they generate, and a lot of that salt is given out into the atmosphere as well. So that is again another method by which the salt is removed from the ocean. Then over a period of time, biological processes carried out by the various organisms, they also keep on consuming the ions and the salts, so that also removes it. Then over a period of time, after some time, you also have many of these salts, they come together, they form a larger solid, they become heavy and they start depositing themselves, so that again dissipates the salts. So you have multiple different factors which keep on adding the salt as well as they keep on removing the salt, right? For example, sea spray, biological processes, etc. So they keep on adding to the salt content. At the same time, they keep on removing the salt content as well, maintaining a kind of a uniformity. Okay? Now, this is basically sea spray mechanism. Okay. Sea spray, what is a sea spray? So, okay, when you consider, let's say, a land area, let's say we consider a land area and a nearby water body. A large sea or an ocean. Let's suppose On the land area, you have a large rock here, right? Like a cliff of sorts. Now, when the waves are generated here, the waves, when they are generated, they will hit this with a significant force. When this is hit with a significant force, it will generate multiple of sprays here, right? Think about it. If you are unable to imagine it, fill water in a mug, throw it on a wall with a significant force. Now, will all the water immediately hug itself to the wall and start dripping? No. Some of that water will be reflected, some of that water will be moved as spray. So a similar phenomena exists here as well. When it hits a kind of an obstruction, that spray is released. Now, some of that spray is carried. So this is your sea spray. So some of that spray is carried to upper atmosphere. And when it is carried to the upper atmosphere, the salts present, they start acting as hygroscopic nuclei. Salts present act as hygroscopic nuclei. Okay, and that will lead to cloud formation, providing a base for the formation of cloud. This is a kind of a rock or a kind of an obstruction, let's say a rocky cliff, right? Generally across the Western Ghats, not across the Eastern Ghats so much, but across the western coastline of the country, if you travel, especially to the south of Mumbai, if you travel across the coastline, you will find a lot of these rocky beaches which are present. All the region around Konkan, that is from Ratnagiri south, Goa, Karwar, Gokarna, in those areas, further all the way up till the famous Cop Beach near Mangalore. Then in all these areas, you will experience significant amount of sea spray which is generated. Okay, right? Why salt has come at the top of the ocean? Salt is present throughout the ocean. It is not only present at the top. It is present all through in the water. The distribution is variable, but it is not as if it is concentrated only at the top. Now, this is what hygroscopic nuclei does. It provides a platform for causation of rainfall. We look at the module 6, revised module 6, we have mentioned that in detail. So this is the salt, and this is how they are distributed. Overall, the most dominant salt is NaCl, that is the common salt, the table salt that we consume. That constitutes around 78% of the overall salts which are present, right? 78% of the overall salts present in the ocean, that is NaCl. So NaCl is the most dominant salt. That is why we have that very unique saline taste when you have the seawater. Then you have MgCl2, magnesium chloride, magnesium sulfate, and calcium sulfate. Calcium sulfate is primarily brought by rivers. Primarily brought in by rivers. Amit, sea spray in Eastern Ghats, you will observe if you go to the region around Vishakhapatnam. Vishakhapatnam is one of those unique areas where you will find a lot of sea spray generated. Even to the south of Rameshwaram, if you go in Tamil Nadu, there also you will find some significant sea spray which is generated. Otherwise also, whenever the waves crash, some sea spray is generated. But if they crash against any particular rock, that is when the sea spray which is generated is humongous. That is very large. Okay. Now, when I say calcium sulfate is primarily brought in by the rivers, Why have I said that? And what is the importance of this? It is important because earlier a lot of geographers used to believe that the prime source of all the salt in the ocean is brought by the rivers. Rivers are the prime source for all the oceans, all the salt which is brought. But then later on, slowly and steadily, they realized that rivers, they carry calcium sulfate. If rivers would have been the prime source of adding salt in the ocean, then calcium sulfate would have been the most dominant. But look at it, calcium sulfate constitutes only around 3.5% of all the salt which is present. So that is when they get to realize, or they got to realize, that salt is added by various other sources. In fact, the river water which comes in, it brings very little amount of salt. Basically, when the river water comes in, if you look at the cross section of the river, let's suppose this is the river channel and this is where the river water is. Now at the base of it, it will have sediments, some amount of dissolved materials will be moving along with it. So it will bring dissolved materials. But majorly, river waters bring what? Majorly, they bring in fresh water. So that is why river water is considered to be a fresh water source, right? And seawater is a saline water source. That is why the species which live in river water, if you introduce them into the sea, they will die, and vice versa as well. If tomorrow you go to a kind of a marine area, you catch hold of a fish, you decide that, okay, I will keep this fish in my home, and this fish was living in this water, it doesn't look nice. I will make this fish live in RO water. I have the best RO water. I have bought a particular kind of RO, which is very good. So I will keep that fish in RO water. Within a few minutes, that fish will die. So that is where the salt content is very important for the survivability of the species as well. Any variation in this salt content tends to significantly vitiate the biodiversity. For example, there are other sources of adding that salt as well. Aquarium at home. Aquarium at home, you usually keep freshwater fishes. Try doing that. If you don't like any of those fish which is present in your aquarium, let's say that fish is not doing very good, do one thing, take a mug of water, add 2 tablespoons of salt in it, mimic a kind of a seawater, and put that fish in that. Again, it will die. So that is where you have freshwater fishes in that region. Okay? Right? So that is how you have the salt content which is present. Now, how is it that salinity ends up varying from one region to another? Now, when you study various different materials, when you come across various different papers, research papers, etc., for the different materials, you'll find that they will tell you that, okay, this region receives high rainfall, this region receives high evaporation or experiences high evaporation, hence there is a variation in salinity, hence the salinity increases or hence the salinity decreases. So salinity tends to decrease based on many different factors: evaporation, rainfall, the amount of rainfall which is happening, the amount of rivers which are coming in, the melting and the freezing of glaciers which is happening, the melting portion, the freezing portion. All these contribute to variation in salinity. But rather than directly rote learning that particular factor, I want you to understand the variation in salinity from the very basic concept. That is, whether any of the factor leads to addition of water molecules in a region or removal of water molecules in a region. Let me explain what we mean by that. So, variation in salinity. Here, we will be analyzing addition or removal of water. Okay? Now, let us understand this concept first of all. What is this concept? So, for example, suppose we consider any small column or parcel of water. Now, this will have the presence of water molecules. Okay. And in the gaps in between them, let us say it has got dissolved salts. Dissolved salts. Okay. Now let us assume this is a region which experiences rainfall. Now rainfall has occurred. So when we say there is occurrence of rainfall, so basically that would mean there is net addition of water or there is net addition of salt. What do you think? When there is rainfall which occurs, is there a net addition of water or is there a net addition of salt which happens? Obviously water. Water is added significantly. That is what we receive with rainfall. Fair enough, some amount of dust particles, etc., might be dissolved, but in majority, water is added. So if I have to represent it again, after rainfall, the condition will be significant addition of water here. And in between them, you will have those dissolved portions of salt. Now, as compared to the first image, in the second one, when you compare both of these, where is it that the proportion of salt is greater? In the first image or in the second image? As compared to water molecules, where do you think the proportion of salt is greater? Proportion of salt is obviously greater in the first one, right? Because in the second one, there is more addition of water. So the weightage of salt has reduced, isn't it? In a way, we can say that salinity has reduced. So whenever any factor leads to addition of water molecules, that reduces the proportion of salts overall, or that reduces salinity. So whenever there is an addition of water molecules, salinity reduces. So we can say that whenever you have significant amount of rainfall, salinity will reduce. We can easily say. We can also say basically that when we have other factors as well, for example, let's say when we have an event such as melting of glacier, let's say an event such as melting of glacier or melting of a large ice cap. Now, will it lead to addition of water or removal of water? Melting of a large ice cap or a large glacier, when it melts and mixes with the seawater, will it lead to addition of water or removal of water? Obviously, addition. If suppose this is a water body, on top of it you have a large ice cap or a large iceberg of sorts, if this starts to melt, if this melts, it will add water to it. After melting, what happens? Adds water, isn't it? So again, because it adds water, that is where melting of glacier again comes into this category. Melting of glaciers. Okay, so both of them will reduce the salinity. Then suppose in a certain area groundwater ends up mixing with the seawater. Will that lead to addition of water or removal of water? What do you think when groundwater mixes with seawater? Again, addition of water. When let's say you have a river water which enters into the sea, will that lead to addition of water or removal of water? What do you think? Again, addition of water. So all these factors which add water, which significantly add water molecules in the system, that will lower the proportionate presence of salt in comparison. So in a way we can say that lowers the salinity level. So for example we will see later on. Then let us consider another condition. That is, in case, let's suppose this experiences evaporation. Now, if ever you have not tried that, I think it is high time in your life that you should try this. If ever you have observed that a glass of water which has got dissolved salts, right? You take 2 tablespoonfuls of 2 tablespoonful of salt, 2 or 3 tablespoonful, and you mix it up so that in that glass of water the salt is perfectly dissolved. You keep it out in the sun. The water will evaporate. Do you think the salt will also evaporate along with it, or the salt will be left behind? What do you think will be the outcome of it? It will be left behind, isn't it? So whenever there is evaporation which happens, the water is lost, but the salt gets left behind. So if this particular water body experiences evaporation, let us assume, it experiences evaporation. So in that case, the water molecules will be lost. Lesser water molecules, but the salt will be left behind. So, in the proportion of the earlier figure, that is, if you compare 1 and 3, which will have a greater predominance of salt, 1 or 3? Obviously 3. So, any factor which leads to removal of water from the system, that will tend to increase the salinity whenever there is removal of water molecules, salinity increases. So wherever you have greater rate of evaporation means salinity will be higher, always, isn't it? Then for example, let's suppose a condition comes where you have a water body in the polar area. Now, due to excessive cooling, the significant amount of this water gets converted into an ice part or an iceberg of sorts. Freezing action leading to ice formation. Now, as a result of this freezing action, do you think there will be addition of water in the system, or do you think water has been removed from the system to form the ice? What do you think? Is there addition or removal? Removal. Water has been consumed to form the ice. So again, water has been removed from the system. So whenever such freezing action takes place, that also will increase the salinity. So this factor again increases salinity. So that is how basically Just by looking at the various different water bodies across the globe and analyzing whether the factors are leading to addition of water or removal of water, that in itself will give you an idea whether it will lead to an increase in salinity level or a reduction in salinity levels. So surface water salinity depends upon evaporation. Whenever there is greater evaporation means more removal of water. So more evaporation means more salinity which is experienced. Then precipitation. Whenever you have lesser amount of rainfall means lesser addition of water is taking place, means more salinity. Areas which receive higher precipitation will always have greater salinity, isn't it? Now, if I tell you, if you consider the region of equator, 0 degree, and if you consider 30 degree, that is the tropics. Now, out of the equator and the tropics, which will receive more rainfall? What do you think? Which will receive more rainfall? Equator, isn't it? The equator will end up receiving much greater amount of rainfall. What about the region of the tropics? Rainfall will be less. What about evaporation in this area? In this area, evaporation is high. Evaporation is significantly higher. Is significantly higher, isn't it? So, if you compare these areas, that is 30 degree north, 30 degree south, and 0 degree, which will have the lowest salinity overall? What do you think? Equator will have lower salinity. Whereas the tropics, they will have higher salinity. That is why across the planet, it is the tropics which will always experience the highest amount of salinity levels. Wherever you have fresh flow of river water, that again decreases the salinity because river water again adds to the water molecules or the water level present. Freezing and thawing of glacier. Thawing here refers to melting of glaciers. So wherever you experience and whenever you experience freezing of rivers, that freezing of river or glaciers rather, freezing of ice, freezing of glacier, whenever you experience such freezing action, yes, some amount of salt will also be frozen, but in majority, you will have water which will be removed. Water in majority is frozen into ice, isn't it? So that is why freezing will always increase salinity, whereas melting will reduce salinity. Okay? So overall, it can be represented by this chart where you have freezing of seawater, evaporation of seawater, all these factors lead to an increase in salinity, whereas factors such as precipitation or rain or snow, melting of ice, river runoff, groundwater meeting, all of these lead to reduction in salinity. Okay? Then we will come to certain factors which tend to add or the horizontal and the vertical variation of salinity, but we'll be taking that up after a break. Let's take a break right now. So we'll take a break for 15 minutes. Break till 6:40. Okay? Let's meet at 6:40 and we'll continue after this. A confirmation regarding the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So these are the factors which contribute to the variation in salinity. Now here, I bring you to another particular figure or a graph or a data pointer, which also helps us analyze how is it that salinity ends up varying across various parts of the planet in oceanic water, obviously. So this is a chart of a comparative representation of precipitation and evaporation, which is experienced in different parts of the planet. The rate at which water is evaporating, the rate at which we receive rainfall, it is the one which describes that particular phenomena. So at the region of equator, we already know that that is the region of doldrums. That is where you have the persistence and the presence of ITCZ as well. It is here that you have the presence of ITCZ as well. So where you have the presence of ITCZ, there will be a lot of rainfall. So observe that the red line represents the precipitation curve, whereas the blue one represents the evaporation curve. So at the region of equator, even though there is evaporation, but there is a greater precipitation, as a result of which salinity will be lesser here. Salinity is significantly lesser. But what about the tropics? Here to here, here to here. Due to the presence of a high pressure zone, that is the subtropical high pressure belt, in this particular area, we experience a significant lack of rainfall in this area, a drastic lack of rainfall in this area. But evaporation is going to be high because the heat is also going to be present. Temperature is going to be high, so evaporation is going to be there, but there is a lack of rainfall. So it is in the tropics that we experience maximum salinity. Maximum salinity is always observed at the tropics. Why? Because of lack of rainfall and a greater evaporation. In general, you will observe that when you come to the region of the poles, the precipitation reduces, but so does evaporation as well, right? So it tends to vary, and in general, we can say that salinity experiences a reduction as we move from the equator to the poles, but it is highest at the region of the tropics. Let us take a look at few of the other features that how the salinity ends up varying. So here, the salinity for normal open ocean ranges between 33 parts per thousand to around 37 parts per thousand, with the average being 35 parts per thousand being the average amount of rainfall which is received. So the average is always going to be, remember that, average is 35 parts per thousand. Okay. Now, for example, you have certain areas such as the Red Sea. Red Sea, if you take a look at the map, is closely bounded by land masses. Land masses are present at very close quarters. So there, in that Red Sea, you will experience what? Greater amount of heating because of nearness or proximity of the land masses. Greater heating means what? Greater evaporation. So whenever any particular landmass experiences greater evaporation, a higher salinity as well. That is why in Red Sea, you can see that overall the salinity is almost around 41 parts per thousand. And basically in areas where you have frequent melting of water, freezing of water, melting of ice rather, water does not melt. So melting of ice, freezing of water. So in those areas, you will experience that salinity ends up varying. For example, in the region around Arctic, salinity tends to vary in between 0 to 35 parts per thousand. That is seasonal, right? It is a seasonal phenomena. Now, overall, this is a representation of the salinity across the world. Observe here, certain very important facts, and I will come back to this image when we study the ocean currents as well. Now, I want you to observe certain areas. Observe the area around the Mediterranean Sea. Now, it is closely surrounded by land masses. So, as a result of that, when it is closely surrounded by land masses, means what? There is greater heating. Greater heating means what? Greater evaporation, means higher salinity. Similarly, observe here where the Congo River exits and meets the Atlantic Ocean, right? Observe that the salinity level suddenly reduces. Why? Because there is addition of fresh water. Similarly, observe here in the region around South China Sea. You have multiple rivers, Mekong and all those, they add water, significant large chunks of water, fresh water, reduction in salinity. Observe the region of Bay of Bengal, compare it with Arabian Sea. Now, Bay of Bengal has got influx of very large rivers. For example, you have Irrawaddy. For example, you have even the case of Brahmaputra, Ganga. Then you have Godavari, Krishna, Kaveri, Mahanadi. All these rivers drain where? Into the Bay of Bengal. All of them supply what? Fresh water. So salinity levels in Bay of Bengal are much lower. Whereas in the region of Arabian Sea, you don't have many large rivers emptying themselves into Arabian Sea. Amongst the large rivers, you will find maybe the presence of Indus and Narmada. But again, Tapi also. But they are not able to add as much water into this larger water body as compared to Bay of Bengal. That is why when you compare Arabian Sea and Bay of Bengal, generally Arabian Sea will have higher levels of salinity. Okay? Now, here, when we take a look at it, basically, in hot and dry regions where evaporation is high, salinity sometimes reaches to around 70 parts per thousand. Maximum salinity is observed in the tropics, but that too in the northern hemisphere, not in the southern hemisphere. Why? Why is it that maximum salinity is observed in the tropics of the northern hemisphere? Because northern hemisphere has got a dominance of land mass, due to which there is a greater heating. Whenever there is greater heating means greater evaporation and hence higher level of salinity. Okay? North Sea, for example, being in higher latitudes, again records higher salinity because of the saline water brought by ocean currents. When we study ocean currents, we will get an idea about this as well. So there is an influence of ocean currents as well, which brings about higher salinity levels in certain regions. So which of them have got more salinity in general? Arabian Sea. Why? Because Bay of Bengal has got greater influx of river water. Greater influx of river water. Now, let us think about certain factors here. When we talk about evaporation, precipitation, river water entering, freezing, melting. Now, if I ask you that are all these factors going to impact the seawater up till the very depth, up till the bottom, or only at the surface level? What do you think? All these actions of evaporation, precipitation, melting, freezing, influx of river water, will they have the influence in overall seawater or only across the surface levels? Obviously, surface level. So all these factors that you see, that will impact the salinity at the surface level. At the bottom level, where the temperature is mostly consistent, salinity levels are also consistent at the bottom level. So whatever variation you observe at the upper level, that will continue only up till around a depth of 400, 500 meters from the sea level, maybe around 1 kilometer from sea level, but not beyond that. After that, at greater depth, salinity is mostly consistent. because these factors of evaporation, precipitation, so rainfall, etc., which happens, it will not influence the water which is present at a depth of 3 kilometers, 3.5 kilometers, and so on. Right? Now, here, let us increase the level of concepts slightly. Let us try to build up on these concepts ever so slightly. So, if I give you two water bodies, let's assume two different water bodies. A has got a salinity of 41 parts per thousand. B has got a salinity of 30 parts per thousand. So A has got a greater salinity, B has got lower salinity. Now, out of A and B, if I were to ask you, which is going to be heavier, A or B? Because both of them will have weight. Which is going to be heavier, A or B? What do you think? Always A. Always. Because salt will also have some weight. If there is greater salt present, so always it will have more weight, isn't it? So can we conclude from this that more saline water is heavier? We can come to this conclusion because of greater salt presence. Anything which is heavier, will it tend to float up or sink down? Anything which is heavier sinks. So can we not say more saline water tends to sink due to weight? Or contrary to it, we can also come to a conclusion that is lower salinity water being lighter tends to float. On top of the heavier, more saline water. We can say this, that water which has got lower salinity, it will be lighter, so it will tend to float easily, right? Now let us think about a situation. Let us think about a situation. For example, let us consider a region as Arabian Sea. Or let us directly consider Bay of Bengal. Bay of Bengal. Now this Bay of Bengal has got influx of river waters, mighty rivers of South Asia. That is Ganga, Brahmaputra, Mahanadi, Krishna, Godavari, Kaveri, larger rivers, Irrawaddy, larger rivers, bring lot of water, means lot of fresh water of lower salinity. Now, what will happen to all this fresh water? Will it immediately mix with the other water as well? No, it will tend to float for some time till it gains a homogeneous property and then mixes. So there, lower saline water will float. Lower saline water floats on top, isn't it? So here, if I were to represent the region of Bay of Bengal, can I represent the verticality of the water level by a factor of lower saline water on top? And then at the bottom, you have the heavier water, which is more saline. Isn't it? So this will be the lower salinity water which will float. Now, this water which is floating has differentiated itself from the higher saline water which is present at the bottom. It has managed to differentiate itself in a way. So here, what we observe is a kind of a vertical layering of water which has been achieved because of variation in salinity, isn't it? There is a kind of a vertical layering of water which has been achieved here. That layering which has been achieved, that is what is referred to as ocean stratification. Ocean stratification. Stratification, again, taken from the term strata, which means layers. So, arrangement of ocean waters in various layers. Now, if you consider this water and you compare it to any other water body, let's say Arabian Sea, which has got a uniformly saline water throughout. If you compare these two, heat is received by both of them. Now, the heat which is received due to solar insolation, that heat will be circulated significantly. If the water is homogeneous, it will be circulated uniformly. But if the water is arranged in the layers, that means heat significantly will be restricted in these layers. Some amount of that heat will then be heating up the lower portions as well. Isn't it? So in this case, because there is a separate layer of water, so that is why that layer of water will get heated up separately, will get heated up more precisely, and eventually it will be able to gain temperature very quickly. So when they are able to gain temperature very quickly and the sea surface water temperature increases drastically, what is the atmospheric phenomena that we observe in tropical waters? Tropical cyclone, isn't it? So can we not say that influx of large amount of river water leads to arrangement of water in the layers? Arrangement of water in the layers means the top layer can be heated separately by the sun. There will be a genuine heating, a uniform heating of the top layer. So the top layer is able to attain higher temperature very quickly, isn't it? That is why the regions of, so this forms another reason why the region of, for example, Bay of Bengal, South China Sea, for example, even the case of Gulf of Mexico, wherever you have large rivers draining themselves into these water bodies, the water tends to get heated up at a much quicker pace. And that is why these are the areas which get frequented by tropical cyclones as well. So this is another reason why Bay of Bengal experiences more tropical cyclones as compared to the region of Arabian Sea, right? So all these factors eventually, as you can observe, oceanic factors, atmospheric factors, all these factors eventually facilitate more formation of tropical cyclones in the region of Bay of Bengal. Okay? So what do we mean by ocean stratification? It is the arrangement of water in the various different layers. Why will the water arrange themselves in various layers? Because if you have heavy influx of fresh water is going to have lower salinity. Lower salinity water tends to float above the region of higher salinity. So that will arrange the water in separate layers. That is what is ocean stratification. Okay? So here, when we come to vertical distribution of salinity, here also we know that at the lower levels, at the bottom levels, salinity conditions are almost fixed. It is at the top levels where the salinity conditions end up varying. So salinity changes with depth, but it is not same at all locations. Then you will have, because at the bottom levels, if you will observe, salinity at the bottom is fixed. Salinity at the bottom levels is fixed, around 35 parts per thousand. right? Now here, on the surface, you will observe a significant variation in salinity levels. If we are at equator, salinity is roughly around 35 to 35.5, right? If you are at the tropics, the surface salinity is significant, 36.5, 37, sometimes even 41. At higher latitude, salinity is significantly lower. So whichever latitude you are talking about, at the lower level, the salinity is almost going to be fixed. So there is going to be a layer, there is going to be a region where there is going to be a sudden or a drastic change in salinity which is experienced before the salinity levels, they fixate themselves at the average. So that is why here you will find this zone of transition being named as or referred to as halocline. Halo refers to salt content. Halocline refers to the variation in salinity. So the sudden variation in salinity, whichever zone of transition that happens, that is what is referred to as halocline. So overall, you can see that halocline is very similar to thermocline, but it measures change in salinity zone, a distinct zone which experiences a change in salinity levels. Surface salinity has been studied under horizontal distribution that we have, and it tends to vary, but salinity at depth is very much fixed. Okay? Then, higher salinity is much more denser, stays below the water having lower salinity, right? Because the density also tends to vary. When you have higher salinity means in the same 1 kg of water, you have more salt content, and lower salinity means in the same 1 kg of water, you have lesser salt content. So higher salinity water will always be heavier, it will sink. So higher the density, then basically it leads to ocean stratification, right? Or arrangement of water in layers. Arrangement of waters in layers, depending upon salinity levels. Okay, that is what is ocean stratification, right? Overall, across the world, some of the highest salinity regions that you will come across, they will be lying across the subtropical high pressure belt, because that is where precipitation will be almost absent, but evaporation will be high. So you have Lake Van in Turkey having a salinity level of 330 parts per thousand. You have Dead Sea having a salinity of 238 parts per thousand. And then you have Great Salt Lake in United States that has a salinity level of 220 parts per thousand. Okay. Umesh, can you explain how salinity, which leads to create layers, which help, how salinity? See, understand Umesh, higher salinity means what? It is heavier. Anything which is heavier will always sink. Lower salinity means what? It is lighter. It will float on top. So that is where you will have arrangement in the form of layers, isn't it? When you have the arrangement in the form of various different layers. So all the layers will receive heat at an equal rate or an unequal rate. Obviously unequal rate. The topmost layer which has separated itself, that is something which is going to get heated much quickly, much more efficiently. That is how you have the variation in salinity. Okay. Why salinity is low at higher altitude? It depends, Sanil. Higher altitude, it is very variable. For example, take the case of Pangong Tso. Pangong Tso is also situated at a higher altitude. Excuse me. Pangong Tso is also situated at a higher altitude, but it is saline. Take the case of Wular Lake. It is also situated at higher altitude. It is fresh water. So even when you talk about higher altitude, it depends whether there is a source of influx of fresh water or whether there is only evaporation which is experienced. In the region of Pangong Tso in Ladakh, there's only evaporation. Because it lies on the leeward side, there's almost no rainfall. That is why it is very saline. Okay. Devansh, as global warming increases, greater melting of glaciers at polar regions will reduce the salinity, hence have the significant impact on marine species. Absolutely, yes. How is it possible that salinity of 41 water at the tropics floats above water of 35 salinity, Neil? Because what does salinity represent? It basically also ends up depicting the density. For example, if I consider 1 kg of water, 1 kg of water having water molecules, right? Now, if the salinity is 41, means you have 41 grams of salt in it, 41 grams. In another 1 kg of water, if you consider, it has got only 35 grams, right? So which will float? Always 35 grams will float above 41 grams, isn't it? Okay, Neil, your question was that how is it that salinity of, see, 41 salinity level that you have, the higher saline regions, so there it is continuous rate of evaporation which is creating that high salinity levels at the surface. It is that consistent rate of evaporation and other environmental factors which are leading to consistent high salinity levels. So even if it mixes, again on the surface you will have higher salinity because of prevailing conditions. And no, Vaibhav, that is not the case. Arshia, correct. Then Pranay, in lower latitude, close water bodies has high salinity. In high latitude, it has low salinity. That is correct. Why salinity is low at higher latitude, Anil? So that is because in those areas you have almost negligible evaporation, isn't it? Almost negligible rate of evaporation. Mostly you have melting which adds on water. That is why very low salinity levels. Then Pravalika, it will mix after some time. And Yaram City, if salinity is there, means why layers of salinity? Any percentage difference of salinity, percentage change of levels. Why there is difference in salinity in various levels, if you are talking about that, that is where we were talking about that all the factors of salinity that we have talked about, they are restricted to the surface, whereas at the bottom you don't have much amount of interference. That is why the bottom salinity remains consistent, whereas evaporation, precipitation, etc., they bring about a change in surface level salinity. Nandini, northern hemisphere will have a greater salary. I don't know about salary. Maybe southern hemisphere also, people also receive the same salary. But if you talk about water bodies, then it will have greater salinity level. Yes, definitely. Then always close water body is having high salinity, Seni. Not always. Not always. If you go to higher latitudes, then that is not the case. Okay. Biswajit, why Bay of Bengal experiences more tropical cyclone? Biswajit, there are multiple factors why the Bay of Bengal receives more tropical cyclone. In this factor, what we have talked about, because of greater influx of river water, which is fresh water, that remains lighter, so that tends to float above, and the portion which is floating above, that gets a kind of a concentrated heating effect, due to which the surface temperature rises very quickly, and that is why more tropical cyclones. Desalinization is removal of salinity. Okay. Difference between halocline and ocean stratification, Arindam. Halocline is the zone at which you have the change in salinity levels. Ocean stratification is the phenomena of arrangement of ocean water in various layers depending upon the variation in salinity. Okay. Vaibhav, can we float in Dead Sea? Yes. In the Lake Van? Yes, you can. See, please understand that there is a principle involved in flotation technique. I'm not going to go into the physics of it. Mass of the displaced water is taken into consideration, and displaced water, if it is very dense, you don't sink. That is why there is flotation phenomena. Brackish water means anything which is saline. What is not clear, Arindam? Your question was difference between halocline and ocean stratification. Listen to this carefully. Stratification, understand the English meaning of what do we mean by stratification. Stratification is arrangement of water in different layers. That is stratification. Why will that happen? That will happen when you have variation in salinity in different depths. And when we say halocline, halocline is a zone at which the salinity tends to suddenly vary. Ocean stratification will not be observed in Arabian Sea. Ocean stratification will not be observed in Southern Indian Ocean. But halocline will be experienced in both of these water bodies. Halocline is where there is a change in salinity levels to come to the lower levels. That will be present in almost all the water bodies, but that is not the case in the situation of ocean stratification. Okay? Can I expect details in upcoming classes for ocean water versus river versus rainwater? No. Why? Why do you need that detail? First of all, ocean water is most saline, then comes river water, then comes rainwater. It is least saline. Okay? So, now we come to the factor of density of water. So, when we talk about water density of water. So density of water is something which is dependent on both temperature as well as salinity conditions. It is something dependent on temperature as well as salinity levels. Okay? Now, when you have colder water, obviously, colder water will have particles which are much closely attached with each other. They are much closer to each other, isn't it? So whenever you have colder water, that will always be more dense, always. So here, water basically which is colder will be much more denser than the water which is warm, isn't it? Now, also, whichever is more denser will always tend to sink. Wherever density is less, that will always tend to float, right? Now, similarly, you have the salinity levels also influencing density. When you have water with high salinity, that is going to be denser as compared to water with low salinity, right? So that is where the density is impacted. And why do we need to understand about density variation? Because that ends up controlling whether the water tends to float in an area, whether the water tends to sink, rise up, and so on. The vertical motion of water is controlled by density variation. So difference in water density affects the vertical mobility of oceanic water, where denser water will always sink, lighter water will always tend to float. Denser water sinks. Listen to this concept very carefully. Okay? Please don't ask me to repeat it again and again and again. So listen to this concept very carefully. This is a very important concept. So denser water will sink and lighter water will float. Means there is a vertical mobility in which is induced. Now, let us consider a situation. For example, we consider the region of tropics. Let us consider the region of tropics. Now, in the region of tropics, What is the temperature of water? Temperature is low or high? Temperature is low or high in the tropics? It is always going to be very high. Why will it be low, Neil? It will be high temperature. Temperature will be very high, right? At the region of the tropics. What about the salinity levels? Salinity, will it be high or low? This will also be very high. Now, how do we determine the density in this case? Because when we say higher temperature means warmer water, and warmer water will have lower density. Warmer water, and it will have what? Lower density. Warmer water basically is less dense as compared to cold water. And what about when we consider high salinity? High salinity means higher density. Higher density, right? So at the tropics, one of the phenomena is telling us that water will be very dense. One of the phenomena is telling us that water will be less dense. This is a contravening act. So which is the one which will give the final property to the water? Will it be lower in density, or will it be higher in density? What do you think? So whenever you come across a combination of both of the factors, always understand temperature will be the driving factor of salinity. So whenever a combination of factor exists, whenever a combination of factors are in existence, temperature controls density. Why and how? Always temperature will control density in this case. How? So let's suppose I give you the case of two water bodies. Let's suppose the salinity levels in both of them are 40 and 41, or let's assume 41 in both the cases. Now, in the case of A, the temperature is 35 degree or 30 degrees Celsius. Even that is very high. So let's assume it is 24 degrees Celsius. In the other one, that is B, let's suppose the temperature is 32 degrees Celsius. So A and B both exhibit high salinity. But due to heating, there is expansion which happens. Any state of matter, due to heating, they will always end up experiencing a kind of an expansion, isn't it? So there, which of them do you think will be lighter or lower density, A or B? Always, it is going to be B. Why? Because here the temperature is leading to expansion, right? Why temperature controls density? Because higher temperature leads to expansion of water, including the salts. So whenever there is going to be an expansion, that will always create lower density. and lower density always ends up floating. Okay, so that is how, because of the impact of temperature and salinity levels, you have variation in density, due to which water in certain areas rises up or sinks significantly downwards. Now let us use this to understand whether it will have any impact on the movement of water from one region to another, whether there will be any impact on movement of water, or at all any movement which will be present in between different latitudes. So circulations due to variation in temperature and salinity. Now let us consider the region between various different latitudes. It is very similar to the circulation that you observe in the region, in the case of air circulation that you observe, it is very similar to that itself. Now let us consider this to represent the tropics, or even the equator you can consider in general, and this let us represent the area of poles. In case we are unaware or we have forgotten, this is high temperature and this is low temperature. Fair enough? Now, let us take a look at the region of the tropics. Higher temperature. So, what will be the impact on the water? Water, due to that incredible amount of heat which is received, tends to expand. And that expansion, believe it or not, gives the water a height advantage of close to around 8 to 10 centimeter around the region of the tropics and equator. Expansion due to heat. Height increases by 8 to 10 centimeter. Right? Regions around the poles, very cold. Colder region leads to things getting compressed. Warmer regions, things will expand. Heat leads to expansion of materials. Colder conditions lead to contraction of materials. This is something we would have read or we would have experienced at very elementary levels. So here, when we talk about poles, the water, because of extremely cold conditions, it will experience a certain level of contraction, isn't it? So here, you have a height gradient. A minute but a significant height gradient is in existence, where water at the tropics are slightly higher due to expansion, right? And water at the poles are at slightly lower height because of what? Because of very cold conditions. So here, slight reduction in height of water due to very cold conditions. Now, this will induce a movement in water. Whether the water will move from poles to tropics or from tropics to poles. What do you think? Water will be moving from tropics to the poles or from poles to the tropics? Water always flows from a greater height to a lower height. So it will indicate a flow towards, very good, from tropics to poles. So water moves. movement of water is observed. Isn't it? Tropics to the region of the poles, water will move. Now, once water starts reaching the region of the poles, there, due to lower temperature, the water starts getting colder. Fair enough. Also, in the region of poles, you experience freezing. So, what will be the impact of freezing on salinity? Freezing will lead to increase in salinity or reduction in salinity. Higher salinity levels always increase in salinity. So as water moves towards the poles, here water gets colder, salinity increases due to freezing, increases due to freezing. Now let us name this event as 1, let us name this event as 2. Now can we say what will be the impact of 1 and 2 in terms of density? Will the density increase or will the density decrease? How will it impact the density? Water, when it gets colder and also the salinity increases, what will happen to the density? Very good. So both of them increases the density of water. When the density increases means water becomes heavier. When the water becomes heavier, then what happens? Water will tend to sink down. Denser water. Whereas in the region of the tropics, continuously, water is getting heated up, expanding and moving towards the poles. So here, from the lower levels, water will rise up to replace that kind of a deficiency, that kind of a vacancy. Again, that water will get heated up and will be sent towards the poles. Right? So that is where the water from the poles, they rush in to fulfill that vacancy. And that is where you achieve a kind of a circulation. Circulation from where? Circulation from low density area to a high density area. And this circulation is driven due to what? This is driven due to conditions of temperature variation and salinity variation, isn't it? Those are the two factors which are contributing to this circulation happening. That is why this kind of a circulation is also what is referred to as a thermohaline. Thermo means temperature, haline means the factor of salinity. This is referred to as a thermohaline circulation. So because of variation in salinity and temperature, the density is impacted. Where at the lower latitudes, the water tends to expand due to higher temperature. That gives it a height advantage, due to which water tends to flow towards the region of the poles. As it approaches the region of the poles, it cools down, becoming more dense, and also there is a lot of freezing action which increases the salinity levels, and both of these tend to increase the density of water. As the density of water increases, the denser water tends to sink. It goes in the subsurface levels towards the lower latitude, where the water is consistently rising up due to the heat and expansion, and that is what completes a circulation that we refer to as thermohaline circulation. So basically, you will find warmer water coming from the region of the tropics, coming to the colder areas near the poles, getting frozen, getting colder, denser water sinks, and then the cold water moves on near the region of the tropics. This allows for mixing of the nutrients in the water, and also this allows for uniform temperature distribution in between the various different latitudes. It is a very important factor which leads to distribution of temperature in between the various latitudes as well as circulations which we observe in the various different oceans. They lead to the distribution of nutrients and temperature. So thermohaline circulation leads to distribution of temperature and distribution of nutrients. Now, if the polar regions, they start getting heated as it is happening due to climate change, the water will no longer become cold upon reaching the poles and it will not sink. So that is why global warming is leading to heating of the poles, due to which this circulation gets interrupted, due to which the heat distribution is not happening, and due to which even the nutrient circulation, that is also not happening. That is why global warming and the heating of the poles, that is significantly impacting the oceanic circulation that we observe. Okay. Atmospheric height at poles is lower. Won't it balance the height gradient? Shrikant, we are talking about water circulation. How is it that the height of the troposphere in the region of the poles and the region of the tropics, how do you fathom that the atmospheric variation? If the atmospheric pressure you consider, still it is understandable. But if you are considering height of the atmosphere or the troposphere, that is independent of the water circulation. And poles, they experience high pressure, very high pressure, right? Surface of lake is frozen in severe winter, but water at its bottom is still liquid, because the freezing happens at the surface, because it is the surface which loses heat significantly. That is why it freezes, whereas the bottom layers, they still retain that heat from the nearby land areas, etc., and that is why it is still not frozen. Okay. Why salt is rejected during the freezing of saline water? It is not rejected. Some amount of salt is still retained. But Sanjay, if you think about it, when you have freezing, what is it? The ice that is formed. Ice is dominantly consisting of salt, or is it dominantly consisting of water? Any ice sheet, any iceberg, any glacier that you see, is it dominantly consisting of salt, or is it dominantly consisting of water? It will always consist of water. So whenever there is freezing action, can we not say that water is removed? Net addition and removal, if you consider, then yes, salt is also removed, but majorly water is removed. So that is why salinity levels increase whenever freezing happens. I think that was your question, Sanjay, if I'm not mistaken. Okay. And Shivani, you also had the same question. I hope that is clear now. Density, Vijay, is the closeness with which the particles are packed. So colder water means particles are more closely packed, hence more density. Warmer water means they are less closely packed, hence lower density. Then we come to the motions observed in the waters, that is in the form of tides and waves. This is not going to be asked in your mains examination. If at all, you will have questions coming in the prelims. So only for prelims. Monica, is it wrong to say that hurricanes can fasten up the salinity in terms of increasing the salinity or reducing the salinity? So that is completely independent. It is driven by temperature conditions, Monica. Hurricanes and the frequency of it is always dependent on temperature condition, right? And whenever you have the occurrence of hurricanes or cyclones, those areas will suddenly experience very high amount of precipitation. And that high amount of precipitation always for the local time period tends to reduce that salinity levels. Okay. Now, why tropics will have high salinity water although it receives higher precipitation? Devansh, why do you say that tropics will receive higher precipitation? See, please don't have this kind of a confusion. Why? Give me a reason. Why do you think tropics will receive higher amount of rainfall? Tropics receive absolutely little amount of rainfall. That means you have not been paying attention to the previous slides that we have been talking about. Observe the tropics. High rate of evaporation, absolutely minimal rate of precipitation. That is why maximum salinity is observed. Okay. Please try to keep up, guys. Otherwise, with this, see, I can repeat the same thing. I can explain salinity for 30 more hours if you ask me to. But then at the later point of time, please don't say that the portion is lagging behind or we are going slow, etc., etc. Please try to keep up. Please pay attention to each and every point so that please don't have many of them. I see that after 4 to 5 slides, you say, okay, do one thing, repeat the entire thing again. Please don't follow that convenient route. I understand concentrating online is something which is difficult, but I also understand that the tricks and trades followed by the candidates, that let me do other things till that point of time, whatever he's saying, I'll tell him to repeat the entire thing. Please don't do that. Okay. Now we come to the portion of waves. What do we mean by waves? Waves are a kind of a vertical undulation created in the surface water. Vertical undulation in the sense that you have a kind of a movement like this. That is what is referred to as a wave. Now, this wave is generated due to what? It is generated due to wind action. So, this is generated due to wind action. Okay, that is what ends up generating the waves. Now, how is it so and why is it so? So, if suppose you consider the water level to be like this. Now, imagine the wind is blowing here. The wind is blowing. Now, this wind will try to pick up the water particles from here. This will try to pick it up, right? Water particles will be picked up here, here, here. But the wind won't be able to carry them endlessly for hundreds and thousands of kilometers. So eventually, this will fall. But the wind is continuous. So again, the materials will be picked up from somewhere here. And again, it will fall. So due to this, you have a motion which is very similar to what you observe here, where you observe that as the waves travel, as the winds bring it about, you have the particles being lifted up and again falling and returning to their same position. So if you have to analyze the motion and the movement of particles in the wave, so always you will observe that the motion or the movement of particles is in a circular or a rotational oscillation of sorts, where if let's say this is a wave, after some time you will experience it something like this. So the uprised portion is what is referred to as a crest, and the downfallen portion is what we refer to as a trough. Right? So after some time, the particles which had been picked up, they will fall down, and here you will have the formation of a trough, and then you will have the crest. So that is how, if you look at the motion of the particles, the water particles, they will generally indicate a kind of a rotational motion. Generally, it will indicate a kind of rotational motion. Always. At lower depths or at greater depths, the motion will be slightly reduced. So if you are asked a question that what is the movement of the particles in the case of wave, is it linear, is it translational, or is it oscillatory rotational? Always the particles, they move in a kind of an oscillatory rotational motion. Okay, that is what generates waves. That is more than sufficient to know about it, at least for the general studies portion. Right? The crashing of the waves, the buildup of the waves, the wavelength in the waves, and how it is related to the depth, that is not important for your general studies. So that is where we will not be talking about it. But there is also a kind, just to make you aware, there is also a kind of a formula, there is also a kind of a mathematic calculation which is involved, which talks about when is it that the waves will become much larger, and that is a factor dependent on the wavelength, that is a factor dependent on the depth of water in a particular region. But again, not important for your syllabus, so let us ignore that. We come to another portion, that is the tides. Now, tides are different from waves. In the case of the waves, you have the formation of a crest and trough. A region which has got a crest, that will get converted into a trough, and a vice versa will also be true. But when we talk about tidal action or tides, that is a vertical rise and fall of water level. The water level significantly, it rises up, it can fall down as well. That is what is referred to as tide. So you would have experienced high tides generally around 12 noon and 12 midnight. High tides, occurrence of high tides means what? Water level has increased. So that is why you would have come across a situation where, let's say, this is the land area and this is the water body. So during high tides, the water level goes up. And that is when you will observe that the water tends to exist somewhere here. So even if you are an individual standing here, under normal conditions, you will experience that under normal conditions, it might be possible that water doesn't come to you, but when high tides comes, it will cover that area. Low tide means water level will go down. So this vertical variation in the water level, that is what is referred to as tide. So vertical motion refers to rise and fall of water in the oceans and seas. Now, this is because of two factors. The occurrence of tides is because of two factors. One is gravitational pull by the sun and the moon. Gravitational pull exerted by the sun and moon. And also due to centrifugal force. Force experienced due to rotation of Earth. Rotation, or rather revolution of Earth around the sun. Now let us take a look at both of these factors and let us try to understand how they induce a kind of a tidal effect or a vertical variation in the height of water. So when we talk about the gravitational pull, so here you have the gravitational pull which is extended or subtended both by the sun as well as by the moon. But because moon is closer, that is why the impact of the gravitational pull by the moon, it counteracts, or it is more dominant as compared to the sun, even though sun is much larger, but sun is very far away as well. So to a great extent, moon's gravitational pull that induces tides. Why? Because of proximity to the earth. Okay, so because of proximity to earth, that is why the moon's gravitational pull will be significantly more efficient, whereas in the case of sun, the gravitational pull will be slightly lesser. Now let us understand how it induces a tidal flow or a tidal movement. So if you think about it, let us assume this is the earth. Let us assume around earth, let us assume the presence of water. This is too much of water. So let us make the rough drawing of water. Okay. So I hope you understand this represents the oceanic areas. Now let us consider the moon, which is present here. Now moon will have a gravitational pull of attraction. Now it will not be able to pull the planet significantly. It will not be able to pull the planet closer to itself, right? Proximity here refers to closeness or nearness. Okay. Now, this will not be able to pull the planet Earth itself, but it will extend a gravitational pull. Due to which what happens is that you have the water which is going to experience a slight amount of pull, right? So in this area, in this region, water is going to experience a slight amount of a bulge. Water is going to experience a slight amount of bulge. Why? Because of gravitational pull of attraction. But if the water is experiencing a kind of a bulge, this bulge is also what is referred to as a tidal bulge, created due to tides. Now, this bulge means there is an increase in height of water in that area. Now, where does this water come from? Will there be suddenly greater addition of water in the world? No. Is it some phenomena that when we see moon, suddenly we open all the taps so that water will bulge? No. Is it because suddenly all the rivers will start emptying there only because that is where the moon is? No. So where does this water for the bulge come from? It will be compensated from other areas. So some water from here, that will move, isn't it? Some water from here, that will also move, isn't it? So what will be the impact due to the gravitational pull? The impact overall, we can say that in these areas, water level will reduce, whereas in these areas, the water will be bulged. We can say that there will be a bulge created, whereas in these areas, water level has reduced, isn't it? So, this region is going to experience high tide. This region is going to experience low tide. Right? This region is also going to experience low tide. Now the planet is consistently rotating around its axis. It is not stagnant. So think about it. Apply your normal and absolute common sense, which prevails. I hope that, even though it is very uncommon, but let's apply. Let's find it out where our common sense is, and let us apply here. That when we talk about a, a system which is in equilibrium, which is rotating, you have two places where the water level has reduced, and one area where there is a bulge. So, what will be the level of water here on the other end? Will the water here also end up reducing? Or will it develop a counter bulge in order to maintain the equilibrium of the rotating planet? What do you think will happen? Beautiful. Very good. It will always try to maintain an equilibrium. Always. So that is why, because it is an independent object, it is not something that someone is rotating it from above. It is an independent object. It needs to conserve its angular momentum, or let us forget that term. It needs to maintain a kind of an equilibrium overall, right? So here, due to this, you will have the development of a kind of a counter bulge as well. So here, you will observe the development of a counter bulge. Why? To maintain the equilibrium, as simple as that. Okay, so here you will have again a high tide. Now, the position of the moon will change. Moon is not always going to be fixated. So let's say the moon comes here. When the moon comes here, this is the area which will experience high tide. This is also going to develop a counter bulge in order to maintain equilibrium. And there, in these areas, there will be reduction. So the regions which had experienced high tide will now experience low tide, and vice versa. Now suppose the moon comes here. Again, the bulge will exist here and a counter bulge will develop here. So it will again maintain high tides. Then the moon can come here. So in 24 hours, an area will experience two conditions of low tide and two conditions of high tide. So that is where the gravitational pull in itself induces the tidal impact, the tidal effect. Okay? Now, this is what you observe. Where the location of the moon is, it develops, it attracts, it creates a kind of a high tide. There's a counter bulge which also develops, and these regions will have water which will move to compensate the bulge which is experienced. Always the side which is facing the moon or the sun, that is going to experience a greater pull or a greater bulge, because that is where the gravitational pull is attracted. So that is where you will have a greater bulge or a greater pull, right? And why does it develop a counter bulge? In order to maintain an equilibrium. Okay. Now, there is another force at play as well, and that is the centrifugal force. What do we mean by centrifugal force? So when any object moves in a kind of a circular or a rotational motion, any object which moves in a rotational or a circular motion, let's say, it will always experience a force acting on the outside. If you hold a string and at the end of the string you attach a ball, and if you rotate it significantly, that ball will always have a tendency to move away from you, to get thrown away from you. Why? Because of the centrifugal force. So centrifugal force in simple terms is the force acting away from center, right? Now here, let us consider the sun. And we do know that planet Earth rotates around the sun in an elliptical orbit of sorts. Let's suppose this is your planet Earth. Again, it is not Saturn. So please don't get confused that he is drawing Saturn here. It is a depiction of Sun and Earth. And Earth. Right? Now, planet Earth continuously moves around the Sun. It keeps on rotating and revolving around the Sun. So, in which direction will the centrifugal force act? Centrifugal force will act outwards. While the Earth is too large and heavy to be pushed by the centrifugal force, but the water will be impacted. And that water, again, will develop, due to that force, the water will develop a kind of a bulge on the outwards. So, due to gravitational pull, you had a bulge created inwards. Due to centrifugal force, you again have a bulge created on the outwards. So that is why on two extremes you will have high tide, and on the other extremes you will have low tide. It is a resultant of both these forces that you have the occurrence of tides. That is the centrifugal force, and the gravitational pull of attraction. Overall, if you want to keep it simple and if you want to forget all the concept of counter bulge, equilibrium, angular momentum, you easily can. Just think about one thing: gravitation will pull the water on the one side. The aspect of centrifugal force that will pull the water on the other side. A combination of both of these will lead to achievement of a kind of a bulge like this. This is what NCERT tells us without complicating the fact that, look, gravitation will be pulling something. So gravitational pull will be having here. The centrifugal force will have a bulge on the other side, and that is why a combination of both of these means a bulge on both these sides. Now, in order to support the bulge on both these sides, by the way, will experience high tides. Water will be extracted from the other regions, and this is where you will have low tides. Umesh, absolutely yes. A very good point made, right? And very good. So Umesh had asked a question that aphelion and perihelion and apogee and perigee will also determine the gravitational pull. Absolutely yes. So on conditions of apogee, perigee, more so as compared to aphelion and perihelion, the impact of the tides or the level of the tides, that also gets influenced. Very good. Now, then we come across the classification of tides, which are in place due to the position of the Earth, Sun, and the Moon. Now we have to understand that the Sun as well as the Moon, they extend their gravitational pull. If both of them, they lie on the same axis, in the same plane, the pull will be in the same direction. So the gravitational pull will be magnified significantly, right? Observe this image carefully, very carefully. So when they are on the same side or at the same axis, Moon as well as the Sun. Now, the impact created by Sun, I hope you are able to look at this portion that is solar tide and this portion that is lunar tide. Solar tide is the impact created by the Sun, lunar tide is the impact created by the Moon. So here you can see that when they are on the same axis, the impact of the Sun and the impact of the Moon, that gets added up, isn't it? So here, in this case, what will happen to the level of water in the case of high tides? Will the water level increase here as compared to the other high tides? Will the water level be same as is the case with the other tides? Or will the water level reduce in the case of high tides? What do you think will happen? Will it increase, remain same, or decrease? Very good, Shamil. So it will increase because the impact of the sun and the impact of the moon, that gets added on. Overall, there is an increase in the level of the high tide by close to around 17 to 25%. That is how much the high tide level increases. Now, what will be the impact on low tide? That is in these areas. Will the low tide level be, as is the case with almost everyday low tides, will the low tide also be higher, or will it be lower? What do you think? Beautiful. This will be much lower as compared to other low tides. Why? Because more water will be required to compensate for increase in level in the case of high tides. So this is a situation where the low tides, they get lower, high tides get magnified. So these are what are referred to as spring tides. And these are observed when the sun, the moon, and the earth, they lie on the same axis. And that can happen when the moon and the sun is on the same side, or moon is opposite to the earth and the sun. Right? So this is a position, a kind of a positioning of the planets, which is also when they are across the same axis. This kind of a positioning is what is also referred to as syzygy. Where when they are on the same side, it is referred to as conjunction. This position when they are on the same side, it is referred to as conjunction. And when the moon lies to the opposite end of the planet, that is referred to as opposition. Opposition. Right? Now, this is what is spring tide. Spring tide is observed in the case of syzygy. Now, here, when the moon becomes perpendicular to the position or the axis of earth and sun, so here you will observe the lunar bulge will be created here, whereas the solar bulge will continue to exist in the normal place. So, if this was to be the region which earlier experienced high tide, what will be the level of water in high tide? Will it be the same? Will it increase? Will it reduce? What do you think in this case of high tide? Very good. It will reduce because the lunar pull will counter the solar pull, right? The solar impact will be countered by the lunar impact. So high tides will be lower in this case. High tides are lower. What about the region of low tides now? So in the case of spring tide, we observe that the low tides are also significantly lower. What about this case? What will be the condition of low tide? Will the low tide be much lower? Will it remain at the same, or will the low tide be slightly higher? Very good. Beautiful, guys. It will be slightly higher as compared to the spring tide, and slightly higher otherwise as well. So that is a condition which is referred to as a neap tide. And this positioning of earth, sun, and moon in a perpendicular direction, in a perpendicular position, this positioning is referred to as what? It is quadrature. Now, how much time does the moon take to move around planet Earth? What is the time taken by the moon to move around planet Earth? 28 days. Okay, those of you who don't know, it takes almost 28 days to complete one full movement around the planet. So it takes 28 days. Now here, if one full complete rotation movement takes 28 days, what is the movement which will be from the portion of conjunction to the portion of first quarter moon, what will be the time taken? 7 days. Again, 7 days to reach here. And there you will have spring tide, again 7 days to reach here. Neap tide, again 7 days to reach here. Spring tide. So can we not say that after every 7 days you have the occurrence of, after spring tide, a neap tide, after neap tide another spring tide, and so on. So this is a type or a classification of tides based upon the position of Earth, Sun, and the Moon. So spring tide, when the Sun, Moon, and the Earth are in a straight axis, the height of the high tide will be higher. They occur twice a month, one on full moon period and another during new moon period. Overall, it should be noted that when Sun, Moon, and Earth, they are on the same line, the position is referred to as syzygy. This syzygy can be of two types: conjunction, that is when the moon and the sun are on the same side, and opposition, when the moon and sun are on the opposite sides. Okay? Then we have neap tide. Neap tide generally comes after the 7-day interval of the spring tide, right? So 7-day interval exists between the spring tide and the neap tide. The sun and the moon are at right angles to each other, and forces of the sun and the moon, they tend to cancel out each other. The moon's attraction, though more than twice as strong as the sun, is diminished by the counteracting of the sun's gravitational pull. So here the high tide is lower. High tide is much lower. Okay? Now, then, when we talk about the various different impacts of the tide, you have to understand that this rise and fall of water, that oftentimes gets exaggerated or diminished as well by the factors and the features of the coastline. The geographical and the geomorphological features of the coastline, that also ends up impacting the rise and fall of water. For example, when you have a very wide continental shelf as in very larger one. So continental shelf generally has got a very little amount of gradient. Let's suppose. Now here, let's assume this is the water level. Now, if there is a slight high tide, if there is rise of water by a slightest level, that means if the water exists up till this level, let us assume, that means this will come significantly further inland, isn't it? The distance covered will be very significant here. Whereas again, during low tide, you will have water which will reduce significantly. So between the high tide and between the low tide, you have a lot of distance which is covered. Water might cover kilometers of areas due to high tide and low tide. This is a feature which is observed in one of the very specific and unique beaches in the region of Odisha, that is the Chandipur beach. Now, Chandipur is one of those beaches where during the low tide, water retreats by few kilometers. And again, during high tide, water goes for a few kilometers, goes in for the few kilometers. And this is where that change is happening because of a very wide and a gradual continental shelf in existence. That is what leads to such drastic motion and movement induced in water or observed in water in general. So that is where UPSC also has asked this question in 2017 prelims, that where in India do we experience such variation in water levels in between the various different high tide and low tide, and the answer was Chandipur. So that is where in Chandipur, if you ever happen to go to Odisha, do visit Chandipur. An entire tourism industry has thrived based upon this particular feature, where you will find that during the low tides, as the water recedes, the restaurant owners, the shack owners, they will bring their plastic tables and chairs. They will put it up. They will serve you food. As soon as the conditions of high tide comes in, they will take it back, and the water fills that area. So that is a very unique phenomena observed. Uh, yes, in Gujarat also it happens, Gagan, but not to the extent as it happens in Chandipur. Chandipur is very significantly well known for this. Okay. Now, here, does it have any impact on Enso cycle? Tides? No. Tides don't have an impact. See, tides are contributed or controlled by what? Sun, earth, moon, movement of earth. So these are larger forces, and these will be in play regardless of El Nino, La Nina conditions, right? Now, many of the times the shapes of bays, estuaries, etc., that also creates. So wherever you have a narrow inlet, in terms of land masses, and here let's say you have sea, and here you have a narrow bay. So because due to the rise and fall of water, let's suppose there is a rise, so water throughout will rise here as well, everywhere water will rise. Now all that rise in water will be pushed into that narrow area, which will, here also there will be rise, but more water is pushed into this. So whenever you have narrow inlets or narrow outlets in the water body, there you will find significant magnification of the tidal height. Always. Here, yesterday I had given you to mark a location, that is Bay of Fundy. How many of you did look at where Bay of Fundy is? I think it will be easier for us to ask how many of us did not look at Bay of Fundy. So, even if we have not, I would suggest to you that, yes, Karthik, very correct. I would suggest to you, look at the region in the northeastern portion of North America. That is where you have the Bay of Fundy. This is where the high tides, they experience a significant, one of the largest amplifications of tide is experienced in Bay of Fundy. Why? Because of narrow inland, or narrow inlet rather. Narrow inlet and narrow outlet as well. Okay. Can the tides be absorbed in other water bodies such as rivers, lakes, etc.? Richa, absorbed is an incorrect term here, but where you have rivers which enter into the sea, the tidal movement can bring about a rise of water in the river as well for a temporary duration. That is true. It is observed in the region across river Hooghly. When it enters and meets the Bay of Bengal, at that region around Sagar Island, you will observe that periodic rise and fall in water level, if you observe carefully. Now, sometimes what happens that when you have two small islands, two islands of sorts, or a narrow inlet. Now, if suppose water significantly rises up here, so automatically it will be funneled through this area with a significant amount of force. And then let's suppose the water recedes or falls down during low tide, that again will come back with a significant amount of force. So that is what is also referred to as tidal current. So when tide is channeled between islands into various bays or estuaries, that induces a sudden rush and flow back of water, which we refer to as tidal currents. Now we come to the portion which is actually very relevant for your examination. So this is going to be relevant both for your prelims as well as for your mains exam. Yes, Nitesh, very good. Now, that is ocean current. What do we mean by ocean current? So when we talk about ocean current, these are the oceanic waters which indicate a kind of a regular flow in a definite direction, and continuously they carry significant volumes of water from one portion to the other. That is what is referred to as ocean current, right? Current here, please don't mistake it with the current that you have or that you experience when you touch a power socket with wet fingers, etc. That is a different current. This is a different current. Here it indicates a streamlined motion, a streamlined movement of flow. That is what is an ocean current. Now, this ocean current is something that mankind discovered long time back. It was around the 1400s when you had the Portuguese explorers who were exploring the entire world and the sailors who were sailing to different parts of the world. They experienced that the water in the oceans, they are not still as they appear. They are consistently moving in a certain direction, and they refer to it as the ocean currents. Now take the case of the very infamous airline disaster which has happened in recent times. That is the Malaysian Airlines MH370, the Malaysian Airlines flight which disappeared out of nowhere. Now it is said that it disappeared or it finally crashed as per the estimates and as per the predictions. It is said that it crashed somewhere in the northeastern region of Australia. But few of the remains or the fuselage or the parts of the airplane body, where were they found? They were found near the coastline of Madagascar, thousands of kilometers away from Australia. So how is it that the airplane parts could have traveled so far away? Because the oceanic water is consistently in motion. It is constantly moving from one area to another. That is why they are able to transport themselves. So this is what is an ocean current. So they are like river flow in oceans. And here you have regular volume of water which moves in a definite path and a definite direction as well. Yes, Shivam, but it is not a very good documentary, so I would not suggest it. But yes, Netflix came out with a documentary with it as well. Now, here, ocean currents are influenced by two types or two categories of forces. Primary forces that initiate the movement of water, and you have secondary forces which provide a kind of a directionality to that water. We will study about this tomorrow in detail. Before that, I would heartily recommend all of you, significantly suggest to all of you, please revise the portions that we have done today. That will help you understand what we are going to do tomorrow. Tomorrow is going to be the last session where you have to apply logic. After that, once the Indian geography starts, logic is not required in that. In that, all that you need to do is to stay awake, right? That is all that is required out of you. After that, the PPTs will have enough text, and anyways, that portion of Indian geography is very similar to how you study polity, how you study history, etc., where the previous concept does not necessarily lead to the next concept. So tomorrow is going to be the last session of physical geography. So till tomorrow, kindly revise. Tomorrow is when we will be initiating the discussion for Indian geography as well. Okay, now let us take a few questions. In just a moment. Right. Anil, when we cover human geography, Anil, are you aware what are the portions in human geography? If yes, kindly let me know. Many of the times I see this. When we will cover biogeography, when we will cover economic geography, and we realize that we have already covered that. So that is why, Anil, I am telling you, don't worry. I will cover human geography as well. I will cover economic geography as well. I will cover biogeography as well. And we have significantly covered world geography as well. analyze after the end of the last class that which portion is covered, which portion is not covered. Human geography includes the portion of population, settlement, and not even transport. So population settlement, when is the last time you found a question in the examination being asked from what is the settlement pattern? In the prelims or in the mains you get questions for that, but in prelims you don't get, right, for human geography. So it is, if you understand the portion of physical geography, my dear friends, the entirety of the geography will be a cakewalk. Okay, so please put all your attention, all your focus in understanding physical. This is how you study the world geography. I'm sure on Monday I will also get a question when I come to Indian geography. But sir, what about world geography? I saw it in the syllabus. There is written something world geography. I have not seen this in unit. So this is how we cover the entire world. Okay. Is there any influence on weather observed on Earth due to high and low tides? Not significant, Siddhant. No. Thank you for the kind words, Sanil. And if that is the case, I hope you know the reason. I hope now if somebody asks you the reason why Delhi is receiving thunderstorms right now, I hope all of you will have a proper explanation of it. Come on, let me know. Why is it that Delhi is experiencing thunderstorms, heavy thunderstorms and lightning as of now, during the past couple of days? Even though I've said it in the class as well, but why? Pranay, why? Why that intense low pressure? Good, Abhishek, very good. Jasmeet, good. Shiva, how can pollution lead to rainfall? Aman, very good. It is due to western disturbances. Remember, we talked about western disturbances. They influence till March and April as well. It is that western disturbances which are creating that intense low pressure, which is creating those cumulonimbus clouds, which is creating the thunder and lightning. Okay. Gagan, what is the name of phenomena in water? Hydrothermal. That hydrothermal heating which is present. Jasmeet, what is the frequency of high and low tide at a particular place? So generally on an average, you will observe that in any coastal area that you go, 6 a.m. you will have low tide, 12 p.m. in the afternoon, high tide, 6 p.m. in the evening, again low tide, 12 a.m. at night, again high tide. So 2 low tides and 2 high tides in a day. Yes, Abhishek, and that is the precise, even in the region of Western UP, many areas other than Bareilly as well, you will find that this is happening due to Western system. That is how interrelation, if you are able to do, then trust me, even if somebody wakes you up in the middle of the night and asks you what this Western disturbance is, you'll be able to tell something near about. At least you will not commit mistake in the prelims questions. At least that will happen. Neil, revise it. It will happen. Don't worry. Revise slide by slide. Bermuda Triangle, I'm not going to come into that, Biswajit. The Bermuda Triangle, Ram Setu, and a few of the other controversial things and the conspiracy things, that lunar landing, all these things, regardless of howsoever you try to pull me into it, I'm not going to get into that. Just to give you an idea, there is a magnetic anomaly which happens there, due to which the compass that stops functioning in certain areas, due to which you have deviation and getting lost factor which happens in many of those areas. But I will strictly not enter into the conspiracies of Bermuda Triangle, Ram Setu, and any other thing which is controversial. Even lunar landing, I'm not going to get into. Regarding the, okay, Pranay, you were asking about the documentary. Basically, if you take a look at it, see, the documentaries which will help you. One is, if you want to understand the larger origin of universe, Big Bang theory, etc., then you should watch Cosmos. One of them is older. that is depicted by Carl Sagan, and the newer one by Neil deGrasse Tyson. That is also something that you can watch. You can always watch Our Planet. This is something I would heavily recommend. Okay, you can also look at Our National Parks. Okay, and more evaporation means more precipitation. Not always so, Karthi. Does not mean so. In any place, let's suppose here, if there is a water body, now if there is a consistent wind movement, means what? Whatever evaporation will happen, it will be taken away, means more evaporation will happen. Right? Generally, you would have observed if you put a wet cloth in the windy condition, it will immediately be dry because more evaporation does not mean it will rain more. Okay. Blue Planet is also good. Planet Earth is also very good. Weber, yes. Himanshi, the northern Pacific and northern Atlantic Ocean have greater range of temperature than the southern parts. It is not so much exaggerated in the case of Pacific, but in Atlantic it definitely is due to proximity of the landmass. Harshita, absolutely yes. Shivam, map pointing from live class and from tablet are both different. Slightly yes. But overall, see, as I tell everybody, map pointing should be explorative in nature. Think about it as if you are getting to know a new place. So that is where you should have that curiosity. Where is that Bay of Fundy? What are the regions around it? So that kind of curiosity, with that, if you approach the atlas, you will not be required to look at any of the maps. But Shivam, you can follow either one of them. Yes, Umesh, that is true. And okay, what is this? What is what? Okay, so that is where we'll end the session here. Tomorrow, when we get back, we'll finish this and we'll enter into the portion of Indian geography after discussing a few of the PYQs. So, till we meet again tomorrow, take care of yourself. Thank you. Have a good night and goodbye. Thank you.